In this lesson, we're going to talk about 2D adaptive clearing. 2D adaptive clearing is a rough milling process that removes the bulk of stock from the raw block around the model. This is an extremely powerful toolpath. 2D adaptive uses an advanced strategy of milling motion commonly referred to as high-speed machining. High-speed machining, or HSM, involves taking a lighter width of cut, the side cut, a longer depth of cut, and creating a toolpath motion that flows. There are no radical changes in direction on HSM toolpaths. The 2D adaptive toolpath can be found here under our 2D toolpaths group on the toolbar. As a default, all toolpath motion is in a climb cut rather than a conventional cut, giving you a better finish and better tool life. Instead of making right-angle moves off of the workpiece, the adaptive strategy calculates arc motion that blends onto and off of the part. The result is a smooth, fluid motion that keeps the machine from jerking between moves. This reduces tool wear and tool breakage due to the NC path's consistent cut volume. Some people think you need to have a modern machine with an expensive high RPM spindle to take advantage of HSM. This is not true. Every NC machine can benefit from an adaptive HSM toolpath motion. On our 2D toolpath group, let's select the 2D adaptive clearing icon. On the Tool tab, press Select to pick our cutting tool. If you click the document heading, Intro to 2D Machining, the middle section will show only the tools for this project. Pick tool number 2, the 1/2-inch diameter flat end mill from the list, and press Select. For now, we will leave the default speeds and feeds for this tool. Let's go to the Geometry tab. We want to start by removing all the raw stock between the outside of the model and the stock block as defined in our setup. Let's look at the tooltip for the Geometry group. This shows us that we can use 2D adaptive to do a variety of cutting types. We can cut a closed pocket, an open pocket, or cut the outside to leave a boss standing. We want to start by cutting the outside to leave the boss standing. Pick the lower edge of the model. This chain will represent the boundary limit for machining and also the final depth of the cut. Immediately, you will see a blue area representing the stock to be removed. With no other selections, Fusion will assume the stock boundary is the outer machining boundary. The 2D adaptive toolpath will clear away all the stock between the outer stock boundary and the profile selection. Let's go to the Heights tab. We can see that our bottom height is set in reference to the selected contour. We actually want to cut past the bottom edge of the part. Set the bottom height offset to -30 thousandths. Let's go to the Passes tab. On the Passes tab, we can select our cutting parameters. The step-over amount is defined as an optimal load. This is the cutting step in X and Y. It's always best to contact your tooling supplier for the recommended load that your tooling can take, along with recommended cutting speeds. For our example, set the optimal load to 0.1. You also have the ability to set this value as a percentage of the tool diameter. Simply move your mouse cursor over the optimal load value, right-click your mouse, and select Edit Expression from the list. Type in tool_diameter space asterisk space 0.20 and click OK. This is how you can use an expression to set parameters. Now, if you change to a different tool diameter, the optimal load will still be calculated as 20% of the tool instead of a hard-coded value. You also have the ability to make this the default value. Right-click over that parameter and select Make Default. Now, next time we do a 2D adaptive toolpath, it will use this same expression to automatically calculate the optimal load. Stock to leave should be checked. Set the radial stock to leave to 20 thousandths and set the axial stock to leave to 0. This will leave stock on the walls, but not on the floor. Next, check the box to enable the smoothing option. If you mouse over smoothing, it will show the tooltip. Smoothing removes excessive points and filters the toolpath into arcs wherever possible. This will reduce your program size and give your toolpath a better fit. Let's go to the Linking tab. There's really nothing we need to change in here right now, so we will press OK. And there is our toolpath, roughing the excess material from the outside of the stock. In this lesson, we learned about the 2D adaptive clearing strategy, selecting a new tool, cutting past the model edge, setting a parameter using a variable, making the variable expression our default, and roughing a part from a stock block. Press Ctrl+S to save the part, Command-S on the Mac.